My name is Kurt Cham. I'm one of the lead product evangelists here at Ansys on the Discovery team. Today, we're going to be talking about how upfront rapid design exploration minimizes prototyping. Join with me today is my colleague, Senior Application Engineer Walid Rabban. Both of us come from a wide array of CAD experience. Our backgrounds, we are both mechanical engineers by trade, have been at the company. Walid has been at the company for at least a couple of years. I am new to Ansys, but excited to be a part of this team. And today we're going to walk through a couple different workflows on how to leverage Ansys Discovery. Today's agenda is there are 4 key buckets we want to focus on. Now, they're very broad, but we want to show you guys a wide array of different things. Whether it's for those people that are on the call who have a current CAD package, how do you leverage imported CAD data? And what do you do with it, right? And then secondly is when you work with traditional CAD, how quickly is it to iterate? But with inside of Ansys Discovery, we're going to show you multiple options to quickly explore different things. So whether it is, hey, what if I wanted to do this? What if I got rid of this hole or this feature? How will this affect my design? How will it affect the strengths? How would it affect the end result, right? Rather than trying to prototype 4 or 5 different examples and then test them out, why don't we quickly digitize everything, see where we are, and then create a prototype of that one piece once we go through that. So what we're going to be talking about today is upfront design exploration and multiple use cases out there. Now, on top of that is when we talk about design exploration, we want to validate and make sure, hey, will this withhold or withstand certain stresses and strains or certain criteria that we set in place. So we're going to be talking about interactive simulation. Some things to keep in mind too is that what are some of the upcoming events? Please look out on our website for new upcoming webinars for 2020. If you have any specific topics you'd like to see, please reach out to us and let us know what you would like to see for the next topic. And then a big thing that's coming out is our 2020 R1 release is coming out in late January. So make sure to look out for that and upgrade to the next version. We still have plenty of people coming in. So with that said, let's talk about some of the other outlets where you can learn about Ansys Discovery. If you're not familiar with our forum, discoveryforum.ansys.com is where you can find out about tutorials, as well as different application examples. And then our news section, which is our 2-minute quick tips. Everyone sometimes doesn't have time to watch a lengthier video, but if you want just to digest some quick tips on different areas, we came out with the new enhanced auto scan feature. So if you're working with STL files or bringing in geometry and you want to create a watertight solid, we have this really cool feature called the auto scan feature, new and improved. We have quick tip videos on that as well. So definitely sign up for our forum, and this is where you can download the software and get access to all the different content that we have out there. So Ansys Discovery, right? What is it all about? And there's 3 big buckets I like to focus on, and it's about productivity, innovation, and agility. Now, if you look at these quotes, these are our customers. And when we think about productivity, it's all about that quick iteration, right? How fast can I get to that design and tweak what I want? And then innovation, right? When you think about innovation, how do you quickly innovate throughout a process? And then agility. It's all about ease of use, get it up to speed quickly, and being productive. Now, part of this family are 3 key areas. We have the design area, we have the explore, as well as the analyze. And today we're going to really focus on the design and explore. When we talk about design, is that quickly rapid conceptual design or even quickly iterating through pieces. And then 2, exploring is, well, if I do something, how does that affect the strength of the part, right? So we can explore the strength and the forces that are being applied to different types of materials. Now, what is design exploration, right? People saw the title. People hear about design optimization. Now, when you look at this lengthy detail by some of the engineering teams, the University of BYU, it's kind of hard, but we rather show you, right? It's all about showing how easy it is to be productive inside of a software. And my colleague, Walid Rabban, is going to go through, show you guys a couple different examples. We're going to make this as easy as possible, as well as interactive too. Once again, definitely take a look at the forum for additional tutorials. I'm going to hand it off to be Rabat, and he'll dive right in.
Thank you, Kurt. I appreciate it. Kurt, can you do me a favor and just pass the control over to me, please?
Got it. Yeah, go ahead and do that.
Okay, 1 second while we get
this
figured out here. Trying to switch the presentation. There you go. Fantastic. All right. Thank you, Curtis. So, yeah, super excited today to kind of showcase some examples that I have. So, as you know, Ansys has always been a tool, had tool sets that welcome all different file formats and types. And so, though we can open up generic file formats like STEP and IGES and things like that, and even native file formats, some of such as those that you see here on the list, I think one thing that people don't think about all the time is, well, what about faceted geometry or STLs? And so we can leverage that geometry as well in here. So we can look at STLs, VRML files, OBJs, JTs, any of those faceted file formats. And so the first example I want to show you happens to be a scan. Actually, this was a part that was out attached to like a boat, for example. It's like a tie down or a cleat, if you think about it. And what I wanted to do was just kind of take a look at it and explore, its performance, and maybe just come up with a couple different, maybe come up with an idea of how I could make this with less material, maybe, or just kind of gauge its performance. And so, when we think about our tool sets that we have today, some of the traditional tool sets that a lot of us as designers usually have, it's really focused on just, like solids, right? Solids and surfaces. And typically, whenever we're dealing with STL files, there's another software that we'd have to learn how to use and buy, and that's specifically focused on handling those type of geometry scans and such. So what I wanted to expose you to was inside of Discovery, we actually have tool sets that help you work with and clean up and interact with STLs and facets. So here I just did a quick check, and I see that it gives me a little bit of information about the facets, and it also tells me that it's not watertight. So that's going to be really important for me to be able to get this to be watertight. And I can do that right in here in the same platform that we have our geometry modeling tool sets, as well as our simulation tool sets, which I'm going to be showing you today. So I'm going to leverage this AutoFix tool real quick just to get this thing to be watertight so I can start working with it and going to the next step. So we can see here, we've made some adjustments and edits, and I'm going to go ahead and just double check it one more time to make sure that it says no geometry problems are found, and I'm good to go. So I've got this model, and I want to set up a quick little simulation for it just to kind of gauge its performance. If I look at the different views here, you can see there's been quite a bit of wear here on this whole, from clamping it down and things like that. And then I also noticed that by looking at it this way, it's kind of bent in this area here. So this is taking quite a bit of abuse out in the field. I want to see if I can just kind of improve it, or just kind of see and understand how that has happened, and maybe I can lightweight it and things like that. So let's go ahead and just start with my first kind of thought that I had. And I'm going to just leverage some of these easy, accessible sketch tools, which are right inside of the display here. Now, you can probably, are going to be comfortable doing some of these CAD operations in your own tool sets. But again, this is where you're kind of bringing both worlds together, right? You're bringing in the whole faceted world along with the solid world. So I want to be able just to kind of take this geometry that I created here. Now, this is a solid body. It's just a simple little kind of pin here. But my goal here is to cut these holes back out again. So let me go ahead and just create a couple copies of this thing. So easy to use tools like Move. In case I need to do some geometry editing in here, I can do that, which is fantastic. I don't have to go back to the tool that I'm familiar with because it's easy to do that right when I'm in here. So now what do I have here? If I look at what I actually have BREP CAD geometry along with facets. We can leverage both of those in our environment here. I've got tools that allow me to merge, subtract, split, I can mix and match as well. So whether they're, facet model to facet, scan to an STL, BREP, step files, whatever it is, I can kind of use these tool sets to do that. So I'm going to take this bracket and I'm going to cut out holes using all 4 of these pins. So now I have holes. And again, my goal here is to set up a simulation for this. So it's really nice that in the same environment that I'm able to create CAD and work with scan data and heal scan data, I also have the ability to do a quick simulation setup. So here it's super easy. I say create solution. And as a designer, this is the type of environment I want. I don't want to get hung up in the weeds on how do I, clean up my mesh, or what do I need to do on the physics side just yet. I just want to be able to kind of mock something up real quick and understand how it behaves. So today this thing is a stainless steel part, and it's just going to be really quick and straightforward to set up, where I just select these holes right here, and I can easily apply a boundary condition. So in the same way that I can select the surface body, I can select these facets. And so I'm going to go ahead and assign a boundary condition. Now you can see all the different boundary conditions that are available when I'm ready to do a structural analysis, right? We've got our fixtures, forces, moments, pressures. I can even apply some thermal conditions if I want to and things like that. I'm just going to say that these are fixed right now. Super easy, straightforward. And again, this is the type of flow that I want, because I want to focus on letting the design thoughts come out and really having that quickness and responsiveness. The next thing I want to do is actually come in and select all of these facets here that represent kind of this hole here. And my goal is there to apply a force. Now, look how easy it was just to do that, just to select, what does it say down here? 11,706 facets, and then apply a boundary condition to it. I want to, Kurt, have you ever seen a tool that allows you to take STLs like this and quickly simulate on it, all in the same environment? I don't think I've ever seen this in my career so far in the design and simulation world.
Yes, Waleed, I agree. Actually, I have, and it's called Ansys Discovery. That's where I've seen it.
That's awesome. That's a great answer. So what I'm looking at right now, take a look at this. I'm looking at the stresses already on this scan model. So this is a scan that I scanned in. I quickly healed. I bored out some holes, applied some boundary conditions to, and I can already tell where I'm getting a lot of that stress. And you can see that if I'm pulling, if there's a tie down here and it's pulling on it, I'm going to get the stress from the sides. And that's kind of how you see this circle kind of become this weird oblong shape. I can quickly take a look at the deformation as well to understand, okay, when it's pulling on it, this is the type of behavior I'm going to see and expect for this particular part. So one of the things I was thinking of was, just what if I could relocate this hole, maybe bring it a little closer to the center, take a little bit of that relief off of this, skinnier area where there's material, and I don't know, just to see if I get a different result. So before I do that, what I want to do is turn on some of these quick calculators or graphs. It allows me to take a look at things like max stress. Lets me take a look at things like max deformation. So I like to have these things visible so that every step that I make, I can instantly see if that step is better or worse. If that idea that I had was actually something that was good or not. So I'm going to go ahead and just turn off the simulation display real quick, just so it makes it a little bit easier for me to edit here. And then this force here, I'm going to go ahead and delete it. So what I want to do is come in here, and again, how do I move this hole? It's not something that's like a single circular face or a sketch that I can go into and edit. So one of the things I'm going to want to do is leverage more of those faceted tool sets and come in and maybe just kind of white this out here. And actually, you know what? Before I do that, let me just do one more thing, because I know I'm going to need some sort of a kind of CAD representation here to cut that hole out. What's really cool is I just selected those facets again and inserted this cylinder, which I'm going to come back to in just a moment. So let me go ahead and hide that. And I'll show you what my idea is there. But if I go back here, I'm just going to select around all these facets really quickly. If you know Discovery and Space Claim, you know that we're able to quickly select a hole and hit fill. Well, what happens if it's a facet, right? So fill doesn't really is not really available. So what I'm going to do is I'm just going to select a bunch of these facets, hit delete. Now I'm back to this thing not being watertight, but it's okay. We know how to fix that, right? A little bit of auto fix in my life, and then there you go. The hole is going to be closed right off. Now, I did tell you that I created that solid, and that's because what I want to do with this is come back and cut this hole out. Now, let's take a look at where I want to position this hole. So I'm going to use some more eDuce tools just to kind of move it around. The nice thing here is, again, if you think about a lot of your current environment right now, if you're using traditional CAD tool sets, even creating a simple solid like this it takes quite a few steps to be able to position it and move it. Everything has to be dimensioned. I'm not really worried about dimensioning right now. What I want to do is just move the hole to a rough area. If it works, if I see the performance that I want, then I'm going to go choose the CAD tool that I'm comfortable with, whether it's SpaceLame or Discovery SpaceLame or any other CAD tool. And so here I've cut out a brand new hole. It's a little lower, and I just want to, again, quickly see if I get low stress and low deformation here. What I should have done is pause that so we don't get this false kind of reading. But let me go ahead and reassign that force here. I'll go ahead and just kind of select those surfaces again, reassign the force, and I think I'm going to apply a force, something like that, and I'm going to go ahead and push play again. And so now what we want to see is design 1 here in this table was the original one, right? Where I had the simulation running on the existing hole that we had. So that was roughly here. You can see here now with the new location, I did introduce a lot more stress and deformation, which was kind of odd. I thought that by lowering, repositioning the hole, I could probably see a little less stress because it's closer to the bottom. So that's interesting. I never really thought about it that way. So this is just kind of good early feedback just to kind of give me that before I go off and have them try to remake this or, build a prototype and spend that money to try to test it out in the field. I can get that quick and early answer right here, even if it's something straightforward. And again, this is a scan. Now, one thing I want to do here too is showcase this new tool that we have in Discovery, and it's the Topology Optimization. We also know it as like generative design as well. What I want to do is see if I can just take what I have so far, lightweight it, right? Make it lighter, because maybe I want to use different material. Maybe I want to use something that's a little bit more expensive. So it's important for me to consider looking at lighter weight material here. So let's see here. I'm going to probably give it a little something like that. So what I want to do is reduce this by 60%. And I'll just go ahead and hit this little play button. Now, I want this thing to go super fast. So we'll go ahead and just take a look at this thing transform very quickly. What it's going to do is any material, any areas where, I have lower stress or areas where I don't really, can do without material, the software is going to go ahead and make those calculations and tell me only where I need to have material so this thing could be robust and be able to manage the stresses that are going to be applied to it in the field. So take a look at how fast, again, in the same exact environment. I haven't left. I haven't gone and plugged into another software downstream or have to worry about file translation and things like that as I go from one software to the other. I'm here in Discovery, and I went from a scan. I set up a simulation. Now I'm doing topology optimization or generative design as we know it as well, all in the same environment, all within the time that we've had so far together. So this thing I think is done here. And one of the things I want to do is convert this to a step file. And let me tell you why. I work with this one vendor who told me that his software only accepts like step and IGES. So I'd love to be able to send this out as an STL, but now what? Now I need to reverse engineer. This is something that's also been something that takes a long time or usually requires another tool set. Well, we've developed some tools in here that allow you to quickly take what you have, okay, like from this topology optimization, get a nice, clean, smooth STL in case you do have a metal 3D printer or a plastic printer or whatever, or you want to send it out to somebody who's going to kind of print this thing out or make it or CNC it or whatever. And if they need an STL, great. Here's their STL file. It's nice and clean. But what happens if again, that one vendor that I have that needs it in that generic file format? Well, let me go ahead and just take you down one more tool, and that's the ability to convert to CAD. This is that auto skinning kind of feature that Curtis was talking about. Now, this is going to take some time, so I didn't want to eat up precious minutes here because I wanted to show you more examples. So I'm going to let this thing run. I'll show you what the final result looks like on my next screen. And then if you want, we'll come back here just to kind of prove out for those of you that think that, you know, I'm kind of just, this is magic. This is what you're going to end up with here is something like this. We'll end up going back if we have time and take a look at the other session so I can show you what the end result of that one looked like. But I mean, look at this. This is a, you know, BREP model or a NURBS, you know, based model here that I can save out in a step. IGES, Parasolid, ACES file format, you know, 3D DXF, 3D DWG file format, you name it. We can save it and hand this off. So all of this in one tool set. Let me show you some. Let me show you another example. So what do you think?
As you bring up some more things here, just something to kind of point out and reflect on is, in a matter of 10 minutes, we took a scanned file, repaired it, ran a simulation, just to see what exactly was going on with that scanned file. That was bad, right? That wasn't even a great scanned file. Repaired it. Did a topology optimization in real time. There wasn't no smoke and mirrors and let's open up another file to show you the end result or push it somewhere else and then wait an hour to then get a result, all in 10 minutes, right? So when we talk about rapid design exploration, exploring different options, here we were able to explore these different variations of taking just something that wasn't great to start with, and now you have a really impressive result that you can go straight to a 3D printer, right? So didn't mean to cut you off there, but I thought that was just, that's what amazed me, right? Throughout my entire career of engineering, it's amazing to see how quickly we can just explore. Because coming back to that kind of, you know, little meme with Stewie on design exploration and design optimization, people think it's just a long process and you got to go through all these different things. It's like, no, look at how quickly we're doing this today. So fantastic.
Yeah. I mean, yeah. How many times, again, how many times have you had maybe an STL and you've had to basically been told, hey, you need to reverse engineer this. And you're like, oh my gosh, this is going to take me half a day or an entire day, or I got to go use this other software that's hard to use or that I don't use frequently. And to be able just to kind of do it, let the software kind of take care of it for you. I mean, that is really special right there. Let me go ahead and show you another example here. I opened up this step file. And, you know, this was something really interesting. So I work with a group of designers and we were just kind of looking at this part here and, you know, our supervisor walked in and immediately he was asking questions. Well, what we were trying to do was just kind of set this up and kind of explore different options. And, you know, what's really cool that I don't think a lot of people don't think about with Discovery is this could be a good conversation tool, a good tool to kind of sit down and say, what if I did this? What do you guys think? Let's go ahead and do it. But in real time, instead of like, okay, well, you know, we're going to go ahead and send it off to, let's say, you know, Johnny over here, and he's going to come back to us in a week, and then we'll see what's going on. So this is something that we were like saying, okay, look, we have this bracket out in the field. There's, you know, some forces on it here, and this is how it's behaving. And so what we wanted to be able to do was just make sure we just want to take a look at it, understand again those stresses. We want to make sure that we are, you know, making sure this part's going to perform out in the field. So let me go ahead and push play. So this is kind of where we started out. We said, okay, let's just take a look at what it looks like so far, where we've got some stresses. You know, obviously it looks like there's going to be higher stress here, but you can kind of imagine that if I pull on the right side, there's going to be a lot of stress kind of in this central area. These bolts right here are going to be critical to kind of supporting that part of the model and keeping that secured. But then, you know, we said, hey, this looks really good. Why do we need to change this? And well, then that's where my supervisor said, well, there's going to be different versions of this. You know, not all of these little hangers are going to be positioned this way. We've got some that are at different angles. So I want to make sure that, you know, those stresses are going to be below, you know, a particular value for like aluminum, for example. So we said, okay, let's go ahead and just turn on, again, those calculators. Now, the max stress is on the entire volume. So this is something where I may want to kind of change up the calculator. I actually want to look at the max stress, but on the face, right? On one particular face in mind, and that's going to be that fillet face right here. So I can even, you know, program my calculator to be in a specific location, which is great. So now I'm looking at all these things while I'm working. And so this is where we're going to look at, okay, what happens if I use the same exact design here for the model that is 25 degrees oriented, right? So this one is just going straight down in 90 degrees. And again, take a look at this. How many of you can take a generic step file or IGES file, or heck, even in your own native CAD tool today? How many of you can just take something like this and completely change the geometry live without, again, having to go back to a sketch, editing, for example, starting with your sketch plane, modifying the sketch there and having to realize, oh, shoot, there's all these parent-child relationships. I can't make this change real easily. Again, it's one of those things, well, all right, we'll just send Wally to his desk and have him work on this for, 6-7 hours or half the day and come back with something, or, create configurations. And it becomes really, it gets really deep at that point. And what we want to do is just quickly just say, boom, here it is at 25, boss. And you can see here that, yeah, you're right. We are going to have higher stress. So now it becomes like, guys, what are we going to do? How are we going to fix this? Because we're designers, right? This is not something I'm just going to take and say, guys, we don't need to run, final validation simulation. I'm going to take it straight to the bank and go make 1,000 of these. I'm still going to rely on my fellow analyst brothers to help me out with this. But if I can do some of that early, fact finding, some of that early kind of discovery ahead of time, that's going to be valuable for me as a designer, because I can make certain design considerations up front and save some of that kind of what if for that downstream, and just jump right into, hey, let's just make sure this thing is going to be strong enough to, be a certain safety factor, for example, and that it's going to, be able to withstand kind of these particular kind of scenarios. So here, all I did was use a really easy to use tool. I thickened this part here down below. We got lower stress, not only on the face, but in the entire volume as well. We're seeing less deformation. So we can start to think about, hey, if we do something here in the center that adds more bulk, whether it's a rib, whether it's some sort of geometry that goes across, that's what's really going to help at those ones that have those angles that kind of stick out. Now, again, another cool thing here, I'll just throw it in since I'm on this one, is I realized that by thickening it, I've actually added more weight to this thing. So one of the things I want to do is, take a look at the total volume here as well, and kind of just keep that in my back pocket. One additional thing I wanted to do, because what we wanted to do is also, kind of route some sensors to this area. And right now we have to go towards the outside. And so we thought, hey, what happens if we thickened it, which is great. We've got the performance we need to keep going. Let's go ahead and kind of cut out some slots or something to allow for some additional cables or wires to be passed through. So I'm just going to do a really quick sketch right in here real quick, super straightforward. Just kind of pull out a rectangle tool here and just kind of create something maybe right in this area here. And then again, I love using things to make my life easy, like copy paste or, control copy drag. That way I'm not spending a lot of time, having to resketch a bunch of things. And again, I can dimension anytime I want here. I don't want anyone to get the wrong idea, like I'm just kind of, messing around. For this webinar I am, but in real life, I can actually program all these dimensions. I can put precision in here anytime that I want. It's just that right now, what I'm doing is I'm just choosing to actually see that this is a little too big, is that I'm choosing to, kind of just rough something out. It's a conceptual tool as well, which is fantastic. So, I'm used to having to, create everything to work the first time, right? And so actually, let me make sure that I've got also one more thing here set, and that is that cut. So I'm used to having to go into my traditional tool and having to make sure everything is kind of dimensioned and dialed in, and it's just so time consuming. Just come in, do what I want to do, basically think what I want to design very easily, make any adjustments that I need. So I've got these slots here. I know that there's going to be some cable passing. Every time I make a change too, the simulation just recalculates. You're going to see now, hopefully, maybe more than a single design point appear in my graph, and that's because I made a couple changes, and every time I make a change, it's going to report back what the result of that change was. So here I created some keys or some slots. I'm going to be able to route some cables over to this area, plug it in. But did we add some? Did we shave down weight? We sure did, which is great. I shaved down a little bit of the weight, got that to be maybe offset, adding that extra material. It looks like deformation is kind of stable here, which is great. I added a little bit more stress, and I think what it's doing is just looking at this little sharp point here. So I can go in and kind of think about this a little differently, maybe change the location of some of these slots, give myself some more of that, meat back right there. That way I don't have that sharp area here, and hopefully that artificial stress kind of goes away. So, but again, to be able to do all of this, I don't think people today have the ability to do this today. They don't have the ability to kind of just talk shop. And let's just kind of take a look at a couple different scenarios, as a team. Everyone's kind of siloed in their own desks. We rely on one or two experts to do all the work. They're loaded, they've got a bunch of work on their desk, and they're usually, a week or two out before we can get some response. And I'm able to do all this really quickly on my own, again, just to improve the design and keep going. So yeah, let's take a look at some more examples. I think we've been doing, two structural type of examples. But go ahead, Kurt.
No. As you bring up the next example here, I think this is a great time to kind of reflect back on what we're seeing. Right? Is what amazes me is we're able to rapidly explore and get quick updates on if this is going to work. Right? Meaning that can this withhold the same stress you applied? Right? Not having to rerun and then wait and rerun. It's not like you have a server in your garage or you have some type of supercomputer. That's the beauty about Ansys Discovery, is that we're able to quickly iterate throughout this entire process. And that's the goal here, right? Is, both of us work with a lot of customers out there. We have a lot of customers on the line. I see a lot of familiar faces. So please don't hesitate to reach out. If you want us to work with you, we're more than happy to as well. But a lot of people will go on site with their own customers and leverage Ansys Discovery just to quickly iterate in real time, get results, and then come to an agreement with their own customer, and then move back and then move throughout that design process, right? So don't think that this is just something you got to stick in, do by yourself in a cube and run it out. Like, people are collaborating and interacting just because the results are so quick here at what we can get. Please carry on. We have about another 5 to 7 minutes. We want to open up the floor. I've been answering questions as they come in. Please ask questions, and we appreciate you guys being here. So Willie, back to you.
Thank you. This is a model here that came from another native CAD tool, and I think what's really cool to point out here real quick is that we recognize things like instances and things like that. So you can see here I'm making a change, and it kind of changes all the children of that particular part. So that's pretty cool. So you can read in your native CAD files, make changes, and still kind of have that same feel where you're not doing a bunch of repetitive work. Or since you don't have that, that feature in your tree that's, that pattern that you can leverage here, it's okay. We'll still let you kind of leverage that pattern here, which is really nice. So what I've done here is I've just I extracted a fluid domain, or what we call like air or liquid, that's typically in enclosure. So here it's an air volume. You can see here I've made it transparent so that we can see the components inside. And what I want to do is I just want to run a quick little CFD analysis. Okay, wait a minute. Did I just say CFD in this tool as well? So, I mean, again, wow, all these great functionality that we typically see in their own siloed softwares, their own, separate locations, or with a specialty of one particular person or a couple people in the company. I've got all those tool sets here. And as I'm a mechanical engineer, I'm a designer, so I understand how these things work. And this is perfect for where I'm at right now. So I like to be able to have this type of functionality. So I'm going to go ahead and just assign this as air. I'm going to say this is my air volume. So super, super easy to assign conditions to it. And again, you're probably thinking, why would I want to make any design changes here? Well, that's not my goal today. Like right now, like initially, I just want to simulate it and just kind of take a look at its behavior. But maybe as a result of setting this up, I may see things where I may want to be like, what if I want to make a couple changes? And that's the beauty. Again, I just keep repeating that because I think people need to hear it, that what if, right? A lot of times, maybe you might be, let's think about it this way. You might be, in the business of consulting, right? So you've got some Ansys tool sets, you've got native CAD tool sets, and you want to get some more work. So you're thinking about bidding on some new work, and a lot of that takes kind of mocking something up and kind of creating some little subset on the side, so it helps you do your estimations better. Imagine having this in your tool set, right? You don't want to spend a lot of time because you haven't won the job yet, but you want to quickly set something up, run a simulation, maybe get some understanding, put some numbers down, some hours down, and know, all right, this thing's going to take this amount of time, and then you go bid on the particular project as well. So think about it that way as well. So I've assigned some boundary conditions here. I've got a flow velocity here where this fan would be. I've set some pressure conditions on those exhaust fans in the back. And I'm going to go ahead and just run this simulation real quick. Now you see here, I did this once before where I can adjust the speed and fidelity. You know, at any time you could get more accurate results by leveraging more of your GPU. Now, I never talked about that. So Discovery runs this particular exploration aspect of it runs completely off my GPU, which means if I have a smaller GPU or a larger one, it's okay. I can leverage this slider bar to kind of get that performance that I want. And at any time I can see, okay, what's that minimum capture size, right? In case I want to compare this to a colleague or something, and we both have different GPUs. But I'm just lowering the speed here because for the sake of this webinar, we want it to go a little faster. And so that we can get to the next example or get to your question. So you can see here in a matter of seconds, I'm looking at the velocity as it's going through here. Now this display doesn't show us the inside. So let me go ahead and make some changes here. We can change the kind of rendering here, like something like composite might be super helpful to see, where I can concentrate on where I have those higher velocities, for example. So everything is interactive here. There's different overlays. Right now I'm looking at velocity. I'm going to look at temperature shortly and just kind of gauge that. But right away, what I'm looking at here is that this fan's doing a great job cooling down these heat sinks, these components here. But one thing I noticed is that it's this particular component here isn't getting as much air. And you know what? This visual actually may not be enough. I may need to kind of leverage some other visuals. So we've got some other visuals down here that I'm going to look at here, like streamlines, for example. This might be helpful to kind of take a look at and see where I may have dead zones and things like that. Maybe looking at a particle map. Oh, here you go. Now you can see what I'm talking about, right? A lot of the air is kind of going in this area, and then it hits this, and it goes straight out the exhaust. So a lot of the stuff on the left side or the right side isn't getting the air maybe that it needs, but maybe these components on the left aren't getting as hot as this gray one back here. So I want to just experiment with, what if I just move its location, right? What if I can just kind of shift a couple things there and get it to be, get more flow there? So that's going to be the thing that I'm going to be interested in doing, is trying to get more flow there. So again, if you've run a simulation in your environment today, right, whatever tool that you're using, and you come across this what if scenario, you're probably going to take, it's probably going to take a considerable amount of time to go again into your native CAD tool, right? Find where these parts are, edit them either in the context of the assembly or go and edit them manually, or it becomes a lengthy process. And so here I can just say, you know what I'm going to do is I'm just going to rotate these, and I just want to see again, do I get better flow? And then, oops, actually it does collide there. Let me just hit escape real quick, and let me just move these out of the way. And this is the beauty. I can move in any direction I want, or I can just, kind of just brute force, just kind of push them along to the side. And hey, while I'm at it, this back one's probably getting not getting the flow it needs. So let me go ahead and just rotate this 90 real quick and kind of move this along. Again, if I had graphs up and things like that, and it was really important for me to see, what the temperatures were, or, kind of what the velocity was at different times, I can do that as well. But right now, what I want to do is just see if I can improve, get more air to go into the kind of the central area and help this particular component out. So now if we go back and I rotate this 90 degrees, for example, and I want to move this around real quick, this is the type of stuff that would, I wish I had back either in my college days or early on in my career. I think I could have, leveraged this and made some better choices in the design process. But look at that. I basically opened up an avenue here for more of that air to cool these two parts, but also maybe cool some of these ones here on the left that are being neglected. That might be important. I wish I had room for another fan here, and I realize I don't, because I've got this plug here. I've got this other plug. There's this box is really tiny. So now how do I get, air? How can I manipulate kind of this air and have it go touch more of these components and, just get them better ventilation and to keep them at a more desirable temperature? Maybe I can add some sort of a baffle or something like that would really help out. So let me just go ahead and see how I'm going to do that here. Actually, let me go back to this kind of view here. I'm going to leverage this plane, and I'm going to go into a quick sketch here. And this is the beauty is I don't have to be an expert in this tool. Sketching is, using lines, and, extruding is using just simple extrude tools. So if I want to, just kind of try to wing it, I can. If it's something where I want to go look at tutorials, there are tutorials available, which is great. So I'm not kind of just worried about, man, I got to, spend a lot of time trying to learn how to use this tool. It's just really straightforward. You've got them right here. You got sketch tools. You got easy to use editing tools. So taking a look at what I'm going to do, I'm going to take those 2 lines that I just created, and I'm going to extrude them. I'm going to actually turn those lines into useful surfaces just by using our simple tool here called pull, right? Super fast. This is why when Curtis was telling you earlier, like we've used a lot of different CAD tools in the past. This is why something like this is beautiful, because again, we all know how long it takes to be CAD experts and to really maximize and leverage, tool sets here. So I went ahead and quickly did that very quickly using some simple, easy to understand tools. I can still go back and leverage my favorite design tool if I want. There's nobody forcing me to use this application, but I just love it. Every time I have something that makes my life easy, I'm going to take advantage of it. So I'm going to do as much as I can in here before I have to go back and maybe think about where I want to create those final 2D drawings, which I can do in here as well if I want to, but where I'm going to create those final 2D drawings and get something that is, something we can, check into our PDM tool and things like that. So if you're in that environment, you're probably going to definitely appreciate something like this, something that just takes that burden and that heavy weight off. So Kurt, what do you think, man? We did topology optimization. We worked with scan data. We did structural simulation. We did fluid simulation here. I just added some baffles, and this is just crazy that we're able to do it in such a short amount of time. Do you think this is innovative? Is this rapid? When you think of it, is this kind of what you have in mind as well? Is this what you kind of envision or hope for?
Every time I see you guys demo the team, application team, it's amazing, right? And you look at even this example of CFD, there is no other package that will give you CFD from a rapid design exploration side to quickly recalculate and give you results instantaneously, right? Like anybody that uses, has anybody on the call that's an engineer or a designer and always wanted to experiment with CFD, and we're talking not only air, but liquids as well, right? Or air moving over something. Anything to do with air or liquids moving, that's a CFD problem, right? And to quickly get a result back and not have to wait, it's remarkable, right? Yes, we do understand that, hey, look, these are dumb components. Yes, we have to communicate with an electrical engineer because we're moving components and you got to redo the vias and the traces and all that kind of good stuff. But the goal here is to make sure, hey, Mr. Electrical Engineer, before you set in stone where components are, let's just make sure we're getting the right cooling going on, right? This is a perfect example because we're rapidly exploring what's going on and what happens when we move certain things in real time. So with that said, Waleed, I think we're coming up on time here. Let's open the floor to any questions. Feel free to type in the chat. If you mind handing it back over, I'll go over some last minute action items here that we have and then close it out. And this posting will be available on our Ansys website. So I'm going to go ahead and present. So you guys can now get an idea of we'll wrap things out. Once again, if you're looking for some training material, you're looking to download the product, please go to our forum, discoveryforum.ansys.com. This is a great area to learn about all the different type of material we have around there, around Ansys Discovery. We have plenty of stuff on YouTube as well. The engine behind a lot of this, of the direct modeling, is our Ansys Space Claim package. But Ansys Discovery is the overall package of where we're showing from, design to explore in itself. So that is the backbone.